Welcome to section 2.4. This is the chain rule for taking the derivative of a function inside of a function. So we kind of have to think of outside functions and inside functions with this piece. So to start with, we have to think of what is our outside function, what is our inside function. And I bumped a button, I apologize. So for this first one, I'm going to think of my outside function as, I'll think of it as f of x is equal to, I shouldn't use f of x because f of x is in the question. I'll think of it as g of x is equal to sine of x. And then I'll think of the inside function as y equals 3x squared. I'm going to go back, I'll change that x up here to a y. I'll make my point a little bit better. So f of x is g of x if I replace y with this 3x squared. So when I go to take the derivative of the given function f of x, I have to take the derivative of the outside function. Okay, I'm going to do that, and instead of writing y, I'm going to put this 3x squared. So the derivative of sine of x, or sine of y, sine of whatever, is cosine of that inside piece, which is this 3x squared. And now I need to multiply by the derivative of y. Well, if I do my power rule, that's just 6x. So I can write my final answer as 6x times cosine of 3x squared. We like to put our trig functions at the end, just looks a little bit nicer. For this second one, we need to rewrite first. We make this 4x cubed plus 2 all to the 1/2 power instead of the square root. It's the same thing, but this 1/2 is the outside piece, and then this piece in here is the inside piece. So y prime, if I take the outside, that's the 1/2 down in front, keep what's in the parentheses, subtract 1 from the exponent, times the inside piece, well, 4 times 3 is 12, x, subtract 1 from that exponent, and then derivative of 2, derivative of any constant is 0, so I have just that, and now I need to simplify. When I simplify, I know that this blue set of parentheses with the negative 1/2 power, that's going to be going onto the bottom to get a positive exponent. And now I have 12x squared times 1/2, that is 6x squared. So I could leave it just like this, or I could have the square root on the bottom here instead. Either one of those is fine. Those are equivalent forms. For number 3 here, if you've taken trig, this is probably easier to remember than if you have not, but this is the same thing as cosine of x squared. We just write it a little bit differently because mathematicians are lazy. We want to save a little bit of writing. Thinking of it like this, we have the squared piece is our outside, and the cosine of x piece is the inside. All right. So g of x, or g prime of x, excuse me, the derivative of the outside, I do the 2 down, keep what's inside the parentheses, and then 2 minus 1 in the exponent is now just 1, times derivative of the inside, well, the derivative of cosine of x, we have to memorize as negative sine of x. So when I go to finalize my answer, this one's really boring, it would just be 2 cosine of x times sine of x. They're not going to change at all. Now, what I just missed was this negative, which is going to be something that plagues me and everybody else throughout the entire course. I'm willing to bet money on that. We have this negative from the sine of x. We have to keep that with the negative 2 out front. All right. Easy mistake to make. Just make sure before you move on, you always check, okay, did I move that negative where I was supposed to? For number 4, we could do this with the quotient rule, but let's do it with the chain rule this time instead. So I'm going to rewrite this as that. The outside piece is that exponent. So I bring the exponent out front, keep what's inside the parentheses, and then I subtract 1 from that exponent. Times, I need to take the derivative of that x plus 1. Well, the derivative of x plus 1, well, derivative of the 1 piece is gone because derivative of a constant is 0, but the derivative of x is just 1. So I have a final answer like this. Okay, I like to leave my answers with positive exponents, so I just move that to the bottom of the fraction, and we're good to go. For number 5 here, this is where they're going to start to get a little bit more intricate. First, rewrite. I have x squared minus 1 is my inside function. My outside, we have a power of 2/3. That 2/3 comes from this squared and that third root. The third root tells me that's where I get the 3 on the bottom. When I go to take f prime of x, I take the 2/3 out front, keep what's in the parentheses, and then subtract 1 from that exponent to get negative 1/3, times the derivative of the inside, which is going to be a 2x. When I simplify or rewrite my answer, however you want to phrase that, I know that that x squared minus 1 to the third power term ends up on the bottom. There's also a 3 on the bottom, so I'm going to multiply those together. The top had the 2 times 2x, which is 4x. So I'm going to have that for my final answer. Number 6, we are going to get a little bit more complicated. So I know I've gone through some of these very, very quickly. Again, the video, feel free to pause, rewind, slow down as many times as necessary. But this function is going to require us to use the product rule and the chain rule. So I'm going to rewrite f of x first as x squared times 1 minus x squared to the 1/2. So when we take the derivative of this, we have f prime of x is equal to, we take the derivative of the first piece, which is 2x, times that entire second piece, plus the derivative of that second piece. Now that's the part where it's going to be a little bit trickier, because that derivative of the second piece is not just this, what I have written in blue, which is something that people like to want to do frequently. That's the derivative of that outside function, but we still need to multiply by the derivative of the inside function, which is going to be, in this case, negative 2x from this minus x squared piece. You bring the 2 down, keep the negative, all right? But we still have to multiply that by the x squared, okay? Because we take the derivative of the first times the second, plus the derivative of the second times the first. That's our product rule. Now I've got to combine a bunch of stuff. So f prime of x is equal to, this first piece doesn't really change much, so I can leave it just like that. But this second piece, I have to kind of like combine things a little bit. So I know that this 1/2 times negative 2 is going to give me a negative. So I could, instead of having plus, put a minus. And then I'm going to still have this 1 minus x squared, and I'm putting it on the bottom so I can have a positive exponent. And I still have x times x squared, which is going to be x cubed. So that would be my final answer. They get more and more convoluted as you add more pieces in. All right, so this required us to use, technically, we use a chain rule, a product rule, and a power rule, all in that one question. For this next one, okay, similar idea, but now we're going to have to also use a quotient rule. So when we take the derivative, we take the derivative of the outside piece first, which that's 3 down, keep everything in the parentheses the same, subtract 1 from the exponent, times the derivative of the inside. When we take the derivative of the inside, this is our quotient rule. Okay, quotient rule is going to be in that red area there. So the quotient rule says we're going to take the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. So now, with y prime, I have 3, and I'm still just going to write this piece out exactly how it is. But I can combine stuff with that red piece. So I know that on the top here, I'm going to have a 3x squared minus 6x squared. Well, that becomes a minus 3x squared. You know what? I'll go step by step. I won't even try to combine things. So we've got a 3x squared plus 9 minus 6x squared. And then because it's a minus and then a negative, this is going to be plus 2x all over x squared plus 3 squared. So y prime is now 3 times the quantity 3x minus 1 over x squared plus 3 squared times negative 3x squared plus 2x plus 9 over x squared plus 3 squared. It's a terrible squared. Okay, now I'm going to go back and rewrite this with just a couple eraser marks. Okay, there was that whole thing squared. That's the same as this top piece squared and this bottom piece squared. So I could rewrite my final answer to try to make it look a little bit nicer as 3 times 3x minus 1 squared times negative 3x squared plus 2x plus 9 all over x squared plus 3 to the 4th, because I had 2 from right here and 2 from right there. That would be my final answer. They can get very, very messy. You have to make sure you're keeping track of all of your work. So making sure you're doing a new line each time you do something is fantastic. You kind of need to get into that habit or you will get lost. For example, this one is a nested chain rule. It's got 3 layers. So when we have more than one or more than 2 layers, work outside in. So what I mean by that, for this function, we have sine of 4x squared, that thing, cubed. So the outside is that cubed. The inside is as far in as we can go, is that 4x squared. And then that sine of that 4x squared is our middle piece. So f prime of x, we take the derivative of the outside first. So 3 times, keep everything in the parentheses exactly how it is. Subtract 1 from that exponent. That's the derivative of the outside piece. Derivative of, now working outside in, we'd go to the middle piece next. So the derivative of sine of x is cosine of x. So the derivative of sine of 4x squared would be cosine of 4x squared. Then the derivative of the inside piece, which is going to be 8x. So now when we multiply to get our final answer, I have a 3 times 8x, which is going to give me 24x. And then I'm going to have a sine squared 4x squared times cosine of 4x squared. How I went from this piece to this piece is just a matter of notation for writing. So as a quick aside, remember that sine x squared is equal to sine squared x. So in this case, instead of having x, it was a 4x squared. It was just easier to write that way, a little bit neater in the long run. All right, so there is the assignment for you to practice. I hope that this video helps. Again, rewind, rewatch, slow down as much as necessary, and I hope everybody has a great day.